Well, good morning, everyone. I hope everyone is having a lovely Wednesday morning. Thank you very much for joining us for the first part of hopefully a long-standing webinar series we're going to do here at Ultima, focusing around Azure. So we're going to spend about an hour or so going through a few topics that we hopefully think you'll find interesting. And just delve a little bit into that as kind of like an introductory topic for everyone. So just to get a few little introductions out of the way, my name is Chris Kirk. I'm a senior technical consultant here at Ultima, focusing on Azure through infrastructure as a service to platform as a service, automation, DevOps. It's a constantly moving target, as you could probably appreciate with the way Azure is set up these days. And I'm also pleased to be joined by one of my more slightly senior colleagues, Andy McCullough. So he's going to talk a little bit about Citrix in Azure as well. Andy, I don't know if you want to quickly introduce yourself.
Yeah, thanks, Chris. So I'm Andy McCullough. I'm a solutions architect in the modern workspace team at Ultima. My area of speciality tends to be around the delivery of workspace solutions, specifically around Citrix-based solutions. So I'll be talking a little bit about how we can look to leverage cloud, kind of specifically Azure, but also more generally for adding value to your workspaces.
Fantastic. Thanks so much, Andy. So I'm going to basically cover two key topics this morning on Azure, and then I'm going to hand over to Andy to cover a little bit around Citrix, what he was just referring to. So just to kick it off with a little bit of elaboration about what we're going to do with these webinars moving forwards. As I already mentioned, Azure is an ever-moving target, but we want to try and do something interesting for customers and talk a little bit about what we consider quite awesome little areas that you could do a little bit more explanation around, where it's a little tricky to understand, or it's a little tricky kind of just to get your foot in the door for a certain topic. So for today, we're going to concentrate on a little bit of an introduction to platform as a service for SQL. So we're going to explore what that actually is from a SQL perspective, how it compares to traditional SQL that you might be using on premise. And we're going to go through a few things around security, how we do high availability, how DR works, and how we can use automation to leverage. It sounds slightly strange to say, but use automation to leverage cost savings effectively with this solution while keeping the performance at a suitable level. We're also going to talk a little bit about service endpoints. So this is where we can leverage platform as a service with our existing infrastructure as a service. So if certain customers have kind of already experimented with Azure, or they've made the jump, generally speaking, they're going to be using a lot of virtual machines and networking. And this service endpoint feature is a nice little way to make a jump into platform as a service while keeping your kind of infrastructure as a service up and running, and just kind of gradually easing yourself into it. And as we've already alluded to, Andy is going to talk about Citrix and Azure and how we can champion the digital workspace via Citrix with Azure. So to kick things off, we're going to do an introduction into PaaS SQ this morning, starting from the top. I appreciate some of you may have already come across platform as a service for SQL already, but we're going to go through kind of the high level areas, what that actually means for customers moving forwards. So to kick it off, it is still a relational database service that happens to run in Azure. It's exactly the same as what you'll be using a SQL Server or a SQL database on premise. It's just, whereas a platform service, we don't have any virtual machines to worry about. There's no management of virtual machines or patching to worry about. It's all done by Microsoft from a patching perspective. And anything that kind of relates to your virtual machines, like networking, for example, again, we don't have to worry about it. So we're taking away the overhead and perhaps some additional costs, but we're still getting that SQL service exactly as we would on premise. So if I were to load up SQL Server Management Studio and were to connect to what's referred to as the public endpoint, or the HTTPS URL of a PaaS SQL database, it will load up and it will look exactly the same from a database perspective. The way you work with it doesn't change when you're using platform as a service. It's still managed by a SQL Server resource in Azure. There's a little bit of a hierarchy going on where some global settings, such as encryption, a little bit of security, which we'll talk a little bit about in a little while, they exist in this SQL Server resource that sits above the database, and then the database kind of sits below that and has more database style settings within the database itself. So there's still a little bit of a hierarchy going on. But it's more around just how they do global and specific settings for your SQL database, as well as applying on the SQL Server level as well. And one of the other big reasons, as opposed to, including the lack of virtual machine and all that overhead you currently got with SQL Server, is the scalability. It's just the biggest reason, in my view, for moving to PaaS SQL databases and the like that we have in Azure for platform services. It's the fact that we can scale this very easily into very high performance levels, which is, from my experience, is something that customers do struggle with a little bit when they do get busy, is to do that scalability reliably and to a point where they need the performance. And we're going to talk a little bit about that in a couple of slides time. A couple of other things, just to wrap this little bit up. Microsoft do work very hard to keep parity with SQL Server. So it's probably about, from a database perspective, it's probably about 95% parity with what you're doing with SQL Server on premise right now, or SQL Server running in a virtual machine. And Microsoft are always updating this service with that in mind to make sure you're not having to relearn the wheel when you actually migrate to PaaS SQL databases from what you're traditionally used to. It also supports MySQL as well. It's not just Microsoft SQL technology that can use this feature anymore. It's also MySQL. It can do Postgres as well. If any of you are using Postgres for whatever reason, that is also supported under this platform service. And things like HA and DR are built in out of the box with very minimal configuration required, which again is a really big win for customers, where a lot of customers may be using SQL Always On, which is a fantastic feature, but it does require a little bit of know-how to get it working, and you obviously have to keep an eye on it, where with this, it's very minimal configuration on that side of things. So just a little bit about kind of what's actually going on under the hood with PaaS SQL databases, because we know virtual machines. Obviously, the question is how are we actually getting any performance or resource for our database. And the way Microsoft do that is with something called database transaction units, or DTUs. So DTU is an arbitrary calculation that Microsoft have come up with. If you just Google for DTU calculator, it'll probably be the first thing that comes up, or Bing if you happen to be Microsoft. And that is effectively a calculation between memory, CPU, and IOPS to then work out what DTU level you need to fit what is right for your workload effectively. What Microsoft have then done is they've broken this up into different tiers for PaaS SQL databases. So we have a basic, standard, and premium tier. And within each of those tiers, there are sub-tiers as well. So, for example, for the standard tier, you can have an S1, an S, or an S3, for example. So there are sub-tiers to different performance levels. Generally speaking, the basic tier you're going to only use for development, because you can only have up to 5 DTUs and only 2 gig of storage for that. And the backup, which is automatic, by the way, so short-term point-in-time recovery is built into the service. You don't have to configure it. But it only gives you 7 days worth of retention on the basic tier, where the standard and premium tier will give you 35 days for point-in-time recovery, as well as up to 1 or 4 terabytes of storage with your databases as well. In terms of things like long-term backups, you can configure that as well. It's an additional configuration step, but this point-in-time recovery up to 35 days for standard and premium is completely automatic. So it's based on transaction log backups, and it does a full backup every day behind the scenes automatically for you. So just comparing it to SQL Server on-premise a little bit, and this is where I like to kind of talk about a little bit about the, for want of a better word, the gotchas, effectively, that I like customers to be aware of before they plow ahead with this and start using it in anger before we kind of reach that point. And that is to talk about the fact that this is a SQL database that you're viewing. It's not an instance of SQL. So when you spin up the database, that is your viewpoint. You're looking at the database as is. So certain features where you have multiple databases doing kind of a combination of things, that isn't going to work from a PaaS SQL database perspective because you're locked to the database viewpoint. So things like cross-database queries, file streaming, link servers, service brokers, SQL, even SQL agent jobs, they are not supported for a PaaS SQL database perspective. So what we generally find from experience is most modern SQL databases for a particular application generally what's referred to as lift and shift quite well into this because they don't generally end up using things like cross-database queries and cross-database transactions and that kind of thing, where that can sometimes be seen as a little bit legacy. But if you're looking to leverage PaaS SQL databases, this is something you need to take into account with your existing solution, that if you are using these features, you might have to do a little bit of re-architecting with your DBAs on premise before you can actually move that into a PaaS SQL workload. So this is more just for your benefit to realize while there is parity with SQL Server, and Microsoft, like I mentioned, they're working very hard on that. There are certain things that this isn't really designed for. Microsoft have recently released something called PaaS SQL Managed Instances, which is very new. It's about 2 months old in GA, and that does fix some of these problems. But unfortunately, that's quite a big topic, and that'd probably be a webinar for another day. But if you are concerned about this, then SQL Managed Instances is something else that you can check out. That it kind of resolves some of these compatibility issues as well. So from an automation and scaling perspective, it's very important to remember that when you're doing anything in Azure, it's an OpEx-based cost model. And for people on the call that may not know what that is, when you're working on premise, you have CapEx costs or you have capital expenditure, i.e. I'm buying hardware as a one-off, a very large expense. You're not really buying any hardware in Azure anymore. There's not really any of these one-off costs. You're switching to operational costs, i.e. you're buying a service and it's costing you money per hour based on how much resources you're consuming. So for things like PaaS SQL databases, obviously the more performance you put behind it, the more money it's going to cost you in the long term. So we can't do this sometimes traditional thing on premise of we'll just give as much resource as possible to make sure it runs as fast as possible. If you do that in Azure, it's going to cost you quite a pretty penny in the long run. So what we can do from the PaaS SQL perspective is we can sit down and work out when this database is going to be busy, because chances are it's only going to be really busy for a couple of hours a day, and then the rest of the day is probably going to be doing barely anything. So what we can do using automation, specifically in this example, there's a set Azure RM SQL database PowerShell command. We can change the DTU tier, we can change the DTU level or the main tiering level for SQL on the fly without any downtime. So I can write a automation script using an Azure automation account on a schedule to say at 11 a.m. it's done its morning run for maybe a data load for whatever solution you may be using, scale it down to maybe an S0 where before it might have been on an S4. And that will, in the long run, that will save you potentially thousands of pounds by doing that and taking that into account. And just to reiterate, you can watch the scaling operation from an automation perspective, and it will not bring the database offline. If for whatever reason this scaling operation fails, again, it won't take the database offline either. It will keep it online, and it will just maybe report an error back to you on that. So just a little bit about security, which obviously is always a hot topic with any product we're using, regardless if it's on-premise or in Azure. So this does have some compatibility, probably what you're seeing already with SQL Server if you're familiar with that. So we do have transparent data encryption. So things like backup, logs, and the database are encrypted at rest by Microsoft. The certificate traditionally is with Microsoft, and they will rotate that every 90 days for you transparently. There's no downtime when they actually do that operation for you. But there is now a new feature where you can actually use your own certificate with the TDE encryption. Therefore, not even Microsoft, not that they would. I'm not going to say they are going to do something like that. But for peace of mind from a security perspective, you can actually use your own certificate for the TDE encryption in Azure as of about, I think, a month ago, that feature came in. We can also do more kind of GDPR style security features such as dynamic data masking. So for example, we can create some rules against some, say, credit card information and assign those rules to a particular set of users or groups. And if you're running a certain search statements in SQL, it won't bring that information back to view. So you're limiting what information can be seen by what user. And therefore, if there is a security breach against a particular user, that's also going to help you in the long run as well, because they won't be able to see certain sensitive information on that side of things. We also have advanced threat protection, which is in Azure. This is an additional cost of about £11 per SQL Server resource, i.e. you're not paying it per SQL Server database. If you have 4 databases, SQL databases in a hierarchy with the SQL Server resource, you're only paying it once for those 4 databases. And this is going to help you with things like real-time threat analytics from Microsoft about SQL Server injection vulnerability attacks, anonymous login, and that will report back via email to either a distribution group or a particular user that you actually specify yourself. So Microsoft are working on that every day. It's pretty much near real time in terms of the threat analytics that they come up with, and it is a great feature to have for peace of mind on that side of things. A couple of more things. We do have a software firewall because this is a public endpoint PaaS service, like any other PaaS service. We can limit the external IPs that can connect to the PaaS service. For example, you could limit that just to your external IP addresses of your business. So only your office, so only if you're working in the office, can you connect to that PaaS SQL database as well. And in addition to that, this does fully support Azure AD users and groups as well. So you can set up PaaS, you can set up within the SQL database either normal Active Directory users or Azure Active Directory users and Azure Active Directory groups. And it will also allow you to do multi-factor authentication. So if you are using MFA, as in it's prompting you for a access token on your phone, for example, it will allow you to do that from an SSMS standpoint. There's a universal option with Azure AD in SQL Server Management Studio, and that will give you the MFA prompt built into that as well to give you effectively two-factor or multi-factor, depending on how you got it set up, for accessing that SQL database as well for that additional layer of security. And lastly, just on our little journey through, or a little introduction through PaaS SQL, I couldn't leave this without obviously talking about HA and disaster recovery. So as already mentioned in the previous slide, you're going to get 99.99% SLA regardless of what tier you're using for uptime for this service from Microsoft. And even though there's no virtual machines to manage, this is actually leveraging Azure storage in the background using what's called locally redundant storage, which means it's actually copying that PaaS SQL database 3 times in the background. So if you do, or not yourself, sorry, if Microsoft do have a storage failure, you probably won't even know it because the other 2 will just take over. They do commit the transaction logs for each of those copies before and acknowledge that, just to make that clear. But that is all happening transparently behind the scenes, and you don't have to configure that. That's all down to Microsoft on that side of things. From a DR perspective, Azure PaaS SQL databases have this effectively built in, what is referred to as geo-replication. So it will allow me to take a PaaS SQL database and replicate it to any region in Azure that I want to. Now, from a best practice perspective, we always recommend you do the partner region to whatever you're working in. So for example, if you've got the PaaS SQL database in North Europe, then we recommend that you have the copy selected in West Europe. And it will ask you to create a SQL Server resource, and it will literally copy the database, bring it online, and that is it. You can stop the replication at any time. You can force the failover at any point if you really want to. There is a button under the SQL database itself to force the failover. They do have independent connection strings depending on how you got this set up, just to bear that in mind. And you can also have the DTU performance level. You can make that different to the secondary one in order to save costs as well, because that secondary database is online and readable at all times, which is actually quite useful because that means we can potentially do some reporting against that secondary database away from the primary. So we can actually make use of what effectively is a DR database and actually make use of it in the background. Why not? It's online, it's readable. We might as well get some use out of it. In addition to that, well, I mentioned they do have 2 separate connection strings. You can then create a failover group. And this refers to a little bit like a SQL Always On listener. I can create a unified URL between these two databases. And effectively what will happen is I can have, for example, a PaaS web app or an IIS instance connect to that unified URL, and it will manage the failover for me behind the scenes. So if the primary database was to go offline for whatever reason, it will automatically fail over to the secondary for me without me having to do any interaction on that side of things. So that's where you kind of get your true DR and true HA from that. It does have that capability if you do want that on that side of things. So if you do have any questions or queries at this point, we'll try and do a little bit of time at the end for questions. But for the meantime, I'm just going to quickly move on to service endpoints, and then I'm going to hand over to Andy to talk a little bit about Citrix on that side of things. So service endpoints, or to give it its full lovely title of virtual network service endpoints, is a rather small feature that kind of flew under the radar a little bit. It came out about 6 months ago from Azure. It was released into public preview. Went to GA very, very quickly with certain services, and they've continued to add in services over time. And what this effectively allows us to do is connect certain PaaS resources directly into our virtual networks. So rather than, for example, I have a virtual machine in a virtual network and I have a PaaS SQL database, if that virtual machine wanted to connect to that PaaS SQL database, it would go outbound via the public endpoint, which is that HTTPS URL, and then connect to the database that way. What service endpoint allows us to do is it won't go outbound to the public endpoint. It will go under the covers, it will go under the Azure backbone and straight to that PaaS SQL database. And we can set that PaaS SQL database to only allow communication to that virtual network. So it's basically adding a layer of security on top, but then kind of combining our IaaS and PaaS resources together. This is also provided at no additional cost. So you're still paying obviously for the resources that you're using from a PaaS or IaaS perspective, but there's no kind of egress costs from a networking perspective or anything like that. It's just a feature that's provided for you to allow you to have that kind of integration. So this kind of fits in a little bit to what we see for a lot of customers going on a little bit of a journey with Azure, where obviously everyone starts on premise, and then generally speaking, their first foray into Azure will be from an infrastructure as a service perspective, mainly to get the foundations right is the way we often talk about this. So you want to get your virtual networking right, your policies right, you want to get how you're building VMs right, get all that foundation absolutely spot on before we then do a little bit of transformation into platform services. So where I see kind of service endpoints being very useful is when customers are quite happy with infrastructure as a service and they've got it running, and they want to kind of ease themselves into using platform as a service and kind of connect some existing IaaS resources with some new platform services effectively. So you're going from step 1 to step 2, and then you're kind of easing yourself into step 3 effectively before you'll later on probably go full blown and you'll start using as much platform or software as a service as you can moving forwards. So from an integration perspective for service endpoints, connecting our virtual networks to certain PaaS services at the moment, and I'm sure I wrote this slide probably 24 hours ago. I'm sure it's out of date already, knowing what Microsoft would like with Azure. But as of writing, this supports your storage accounts. It supports PaaS SQL databases. It supports PaaS SQL database for MySQL. It supports your Cosmos DB and Key Vault. And currently in public preview, we have Data Warehouse, Service Bus, Event Hubs, and we have our Generation 1 Data Lake Store as well. And Microsoft are adding to this all the time. They're making as much platform services available as quickly as they can for this as well. Just to highlight, some people might be wondering why PaaS Web Apps isn't on this list. That's because Web Apps already have a VNet integration built into them as a feature, and therefore there was no real reason to kind of reinvent another service for that when it kind of already exists under a PaaS Web App anyway. So just to kind of explain from a more technical point of view how this actually works under the covers. So when we enable the service endpoint, we actually enable that against the virtual network in Azure, and it asks us to pick a particular subnet in that virtual network that's going to communicate with a particular PaaS service. So in this example, we'll stick with PaaS SQL databases just as an example. So for my virtual network, I'm going to select the subnet that might have, say, a front-end virtual machine that I want to talk to that PaaS SQL database, and it will ask me what service do you want to enable of the list that we've just seen. What effectively then happens is for the virtual network in that subnet, routes are injected into the routing table for the virtual NIC of that virtual machine. So as you can see in the red box, once I've enabled that endpoint, a new route gets injected called a virtual network service endpoint, and effectively it's injecting the public IP addresses of the PaaS SQL service. So it's effectively saying to this virtual machine, any DNS entries that resolve to any of these IP addresses don't go outbound, don't go via my default route to the internet or any other kind of routes that we have set up like that. Go via this virtual network service endpoint, which Microsoft then have connected to the Azure backbone, and therefore it's then going to go straight to the PaaS SQL database. So it's just to highlight this is not removing the public endpoint for these PaaS services at all. It's not doing that whatsoever. All it's effectively doing, it is rerouting the traffic onto the Azure backbone and then towards these particular PaaS services as well. So there's no kind of IP addresses that it's giving to this PaaS service to reference. It's purely just a redirection of traffic that's being enabled on that point. So to give you a common example that this could potentially be used against, and this is an example I've talked to customers quite a few times about. They will generally have, or you'll generally have, a web application that's got a SQL database as a backend, and you'll find that the SQL database is compatible to run as a PaaS SQL database, but the web application, for whatever reason, that's currently running in IIS, makes use of a few quirks here and there, and therefore it's not suitable yet to be used as a PaaS web app. So unfortunately, that has to stay on the virtual machine until that can be re-architected. But by enabling the service endpoint on the front-end subnet, in this example, via our production VNet, it allows me to directly connect via that redirection of traffic to my SQL database. And then on that SQL database, I can basically set the public endpoint to not allow anything coming in externally, but allow traffic from this subnet and this VNet to communicate with this SQL database. So therefore, the SQL database here can only communicate with this front-end subnet. So you're making use of IaaS and PaaS, but it's effectively securing it as one under the covers. And obviously, this is allowing you to use that scalability we talked about from a PaaS SQL database perspective. It's allowing you to use leverage cost savings because you don't have as much overhead in terms of virtual machines or any of the other kind of common infrastructure side of things as well. So that is it for service endpoint, and that is it for PaaS SQL database, just to give you a little bit of introduction. Don't panic, it's not the end. I'm just going to change presenter to Andy, who's going to talk a little bit about Citrix in Azure.
Thanks, Chris. That was very informative. I think even I've learned something there.
It's a moving target. It's a moving target. Cheers, Andy.
So let's jump in. So as Chris said, I think in terms of the journey to the cloud, I think Chris called it exactly right in terms of it's a journey, and workloads specifically have their own particular challenges when looking at that journey into the cloud and how we can derive value. So as Chris has been talking about, the PaaS SQL service and the platform services as a whole delivered by Azure are really where you derive your benefit from your cloud transformation. And it is a transformation. It's not box shifting. It's not necessarily just moving what you have on premises today into a different hosting location. That doesn't necessarily deliver the value that people expect from the cloud. It's actually the transformation of their solutions to utilize these platform services from the cloud providers that deliver the value that a lot of people expect from adopting cloud solutions. Now, when it comes to workspaces, we've got some quite particular challenges around that, because there aren't actually many platform services that we can actually leverage. If you think about what actually makes up a workspace for a user, we're talking about access to kind of a traditional operating system. So we're sort of restricted in terms of what we can use to the IaaS offerings, the infrastructure as a service offerings from the cloud providers. So where we have to be quite careful when we start looking at workspaces in the cloud is in terms of understanding how we're actually going to derive the value from that journey. Because obviously, if there's going to be no benefits, if there's going to be no cost benefits, if there's going to be no user experience benefits, if there's going to be no business or security benefits, it can be quite challenging to justify that effort, because it can take a little while. It is a journey. So we just need to be careful about how we approach this. So what I'm going to do is talk a little bit about how the different ways that we can start to utilize cloud solutions for your workspaces, and also about some use cases that we're seeing with customers in terms of how we're helping people today to make use of the cloud services that are available. So we're going to start off talking about pizza, which is a bit of a different take, but go with it. It will hopefully all make sense. So we're just looking at the different ways that we can consume things. So if we look at a traditional how you consume pizza, you've got the option, you can make it at home. So you can buy all your ingredients, you can cook it, you can provide an oven to cook it in, you bring your drinks, you've got a dining table, and the net result is that you've got a pizza. And then you've got another option, which would be take and bake. So you go to a supermarket, you buy a pizza. So that's all pre-made for you. But then you've still got to provide an oven to cook it in. You've still got to provide drinks. You've still got to provide somewhere to eat it. Then we can look at having a pizza delivered. So we can phone someone, they can put together all the ingredients, they can cook it for us. It turns up at our door. We've still then got to provide some drinks, somewhere to eat it. So there's still a little bit of effort on our part. Or we've got dining out. We can go out to a restaurant, and in that scenario, everything's taken care of. You've got the food, you've got the table, you've got the drinks, everything's good to go. Now, if we take that example and apply it to how we can handle our workspaces, we've got a DIY approach. So this is what most people are doing today in terms of delivering virtual workspaces to their users. So they're providing the compute, network, storage, they're configuring HA, DR, they're configuring management layer, they're securing the access, providing remote access for users, they're configuring, patching, supporting the OS, and they're delivering the applications into that environment as well. So they're responsible for the entire stack. We can then look at an IaaS solution. So in an IaaS hosted solution, we then take away some of the layers. So in this scenario, we then have the vendor actually taking care of the compute, networking, storage, and the HA. Now we then are only responsible for supporting and managing and operating the management layer, access layer, remote access, operating system, and the applications that users are going to actually consume. Then we can look at the PaaS variety. So this maps most specifically to our Citrix cloud offering. So this is where pretty much the entire solution stack, with the exception of the actual operating system and the applications that users consume, being managed by the vendor. And then we've got a fully managed offering. So this ties most closely to a SaaS solution. So in this scenario, you're purely just consuming a service. So in terms of management and operations, you're pretty much hands off and you can just consume it. So if we have a look at some use cases, so I think the first one that we've been talking to customers quite a lot about in recent months and years really is business continuity. Now, business continuity in the cloud is an immediate win for a lot of customers. So some customers may be in a position where they don't have a DR facility for their workspace environment. So some customers may have kind of a reduced implementation for DR. So they may say, well, hey, we've got 50% capacity in the event that everything goes pop. Or some customers may say, well, hey, we've gone full 100% DR. We've kind of got a DR data center where we've got a fully high performance set of infrastructure there, ready for that just in case day when everything goes pop. Now, that gets quite expensive. So if you think about it, if you're having to duplicate your spend, then your capex costs on that are incredible. So if you're having to buy a set of servers to deliver a production capability, if you're effectively doubling that every time you deploy a server into production, that's a really expensive way to do it for a just-in-case scenario. So where we start looking at cloud as delivering that immediate value is in the context of being able to deliver those on-demand resources, to be able to deliver those that compute capacity, that workspace environment in the event of a DR event, in the event of an outage or a failure scenario, but only actually incurring those costs at the point in time when they're actually needed. So utilizing the cloud for business continuity can actually deliver an extremely low cost DR capability for your workspace environment, which would otherwise be a fairly expensive proposition. So in the context of business continuity, there are several different ways that we can actually do this utilizing Azure and Citrix technologies. So looking at the highest cost and most expensive, we're probably looking at kind of the on-prem option. So this is in a scenario where you've duplicated your hardware, you've got that DR facility, you're buying hardware and kind of duplicating that hardware spend in your DR site. So in terms of configuration, it tends to be the most complex and also tends to be the highest cost. Now, lower cost and probably medium complexity, we're looking at on-prem with a cloud site. So if you have an on-prem solution at the moment, extending that on-prem solution into the cloud and utilizing that cloud site as a DR location can deliver some significant cost savings on the on-prem option, but obviously it still requires a certain level of configuration to actually achieve a good user experience in that type of scenario. Utilizing some of the Azure tool sets. So we also have the ability to use solutions such as Azure Site Recovery to be able to replicate on-premises systems into Azure and actually only invoke those in the event of a DR. So again, that's looking at using the cloud provider's native tool sets to be able to facilitate delivering those services in the cloud. And then in terms of lowest cost and lowest complexity, we've then got a Citrix cloud solution with hybrid cloud. So in this scenario, this utilizes the Citrix cloud hosted management components to deliver production and DR resources across potentially an on-premises site and a cloud site or multiple cloud sites, depending on your requirements. So with the solution being managed out of a cloud-based management plane, this gives us the flexibility of being able to deliver those capabilities from a location of our choosing. So it tends to be the least complexity and also a low cost because we're able to utilize those cloud resources. Now, one thing to consider in terms of business continuity is obviously recovery time. So recovery times can be quite important to a lot of organizations. So we just highlight some of these. So the lighter the color in the circles, the faster the recovery time is. So on-prem to on-prem tends to be the fastest. So obviously you've got the hardware there, it's sat there, it's potentially running hot, you've got the ability to instantly fail over. So some customers we've worked with have had recovery times of kind of like sub 30 seconds to fail over to a DR environment. On-prem with a cloud site, again, not slow. Depending on your configuration, it could be kind of within a few minutes. But again, that's down to some decisions you'd have to make in terms of how much of the infrastructure you'd want to have actually running hot and ready to go. On-prem with Azure Site Recovery tends to be one of the slower options. Now, This is because using Azure Site Recovery, you've then got to invoke recovery. So you've got to restore services from the Azure Recovery Vault, which can take a little bit of time. But again, if you're looking at kind of like 4 to 8 hour recovery time objectives, then again, it's a viable solution. And Citrix Cloud is hybrid cloud. Again, depending on the decisions that you've made in terms of how much infrastructure you have actually stood up in advance, it can be kind of a recovery within a matter of minutes to a cloud location. So one of the other use cases that we see quite a lot is in terms of accommodating surge usage. So this is just an example of an organization's usage of their workspace environment based on kind of seasonal peaks. So if we look, we've got kind of relatively low usage in kind of the spring months, and then we hit the summer and we have a significant peak in terms of system load. So this may be, for example, like a holiday company where kind of in the summer their sales go through the roof and the amount of data they're processing, the amount of sales they're processing hits significant peak. Again, if we look at retail, this peak might be kind of more towards the end of the year to accommodate Christmas sales, Black Friday. So the point we're making here is that we have to determine what our level of capacity is. Now, what we can do is say, well, hey, we've got this peak in usage, so what we need to do is we need to go out and buy more servers. Now, that's an option. You can do that, but then the problem you end up with then is that you've then got a big differential between what you're using throughout the majority of the year versus what you've actually paid for. Now, when you're paying for these servers up front, that's quite an expensive proposition to handle a burst that lasts a matter of weeks. So what we have the ability to do for our workspaces is actually burst to the cloud, to make use of cloud resources to extend our deployments. So where we do have seasonal peaks, we've got the ability to actually use those cloud resources to add additional capacity to our environment, which then gives us the ability to only pay for what we're consuming. So we don't have to go out in advance and kind of pay for a load of additional tin to run our workspaces on. We can then just use the resources that we need to accommodate that peak. Now, Multi-Geo and Multi-Datacentre, as you're on your cloud journey, as you're starting to kind of move things into the cloud, I think one of the kind of staggering things, if you look at Azure specifically, I think, and again, kind of similar position to Chris, could change minute by minute, so kind of don't quote me on this, but I think Azure have got something like 57 regions active at the moment. So 57 locations around the world where you can choose to spin up a resource. Now, that's quite a powerful offering in that you've then got the ability to intelligently place your applications, your services, in the best place to give the best user experience. Now, that's fine, but it can lead to some complexity when you're starting to deliver things in multiple locations. Now, what you can do is start looking at grouping things. So from a workspace perspective, we have some considerations around latency in terms of being able to kind of manage that operations layer, in terms of managing user experience. So what you tend to find using traditional approaches is that you end up kind of grouping resources together. So for example, they may be grouped together based on continents, based on kind of specific network conditions in those environments. Now, one of the nice capabilities we have is using Citrix Cloud technologies. With the solution being kind of hosted and managed as part of the Citrix control plane, we then have the ability to allow our solution to span the globe. So Citrix Cloud, as opposed to on-premises offerings, is designed to operate at internet latencies. So we don't have the same restrictions as we do with on-premises or hosted solutions. We're able to actually intelligently deliver our services from the best location for the user. So again, it gives you the flexibility of choice to be able to say which one of those 57 regions is it best for me to put that resource in that's going to give the best user experience to our users. I think another topic that's quite important to workspaces is Azure Networking. Now, there's been quite a lot of talk about this kind of lately, because there's been some interesting additions to Azure capabilities. So there's a new service which is called Azure Virtual WAN, which effectively lets you leverage Azure's global fiber network as your WAN transit, which is kind of a really cool offering. I won't dive into it now, but if anyone wants to talk about it, please let me know, because it's kind of a really great offering. So Microsoft actually operate the second largest WAN in the world. So you can see from the picture on the screen, they've got quite a significant fiber optic network that interconnects all their regions globally. Now, one of the important things to note is that most people that are looking to move into the cloud are probably looking at things like 365 for delivering mail services and productivity applications. Now, one thing to bear in mind is that if you have your workspaces hosted in the cloud, then effectively when you're accessing these 365 services, which effectively can be quite one of the main touch points for users throughout the day, when your workspaces are hosted in Azure, when you're accessing the 365 services, your network connection to the 365 services don't leave the Azure WAN. So that's quite an important thing. In terms of high performance access to Office 365, the best performance you're going to get is accessing those services from within the Azure network. So in terms of user experience, that's an incredibly important point. Now, this quite busy chart is based on some testing that I did a couple of months ago. It was at the point in time when they started talking about the Azure Virtual WAN offerings, just to kind of understand how much of a difference it was going to make. So this is looking at what the difference in latency is accessing a service from outside or inside the Azure network. So we can see specifically relevant for us, for UK West and UK South, it's around 70% lower latency accessing Office 365 from within the Azure network than it is from an internet-based connection or an MPLS connection. So in terms of user experience, that's a significant benefit, especially when we're looking at things like Exchange Online. The lower the latency, the better the user experience is going to be. One of the major benefits of cloud is you've got the ability to change your mind. So we've got a nice crystal ball on the screen here, and this is kind of what a lot of people will ask you to pull out when you're sizing a workspace solution. So if anyone asked you 5 years ago what your application set would be in 5 years' time, what your business is going to want you to deliver in 5 years' time, you'd probably struggle to actually explain that. So one of the important aspects of cloud is that you've got the ability to pivot as you need to. Now, this could be based on changing business requirements. This could be based on a change in performance context. So one of the kind of big things that we struggle with customers is that as web apps, as the internet becomes more interactive, as people start accessing more HD content, we start to see browsers kind of taxing systems far more. So we can see Chrome here. Chrome using like 2 gig of RAM isn't uncommon. That's a very, very typical scenario we see with a lot of customers. But again, if you've sized kind of low memory footprint solutions, then that can be a real challenge, and that can incur some like immediate additional costs. We've also got other demands that can be placed on the system. So you might recognize these logos. They're from Spectre and Meltdown. So some hardware-based exploits that kind of emerged around the end of last year, early this year. Now, at the point in time when someone says that, well, hey, we need to deploy a patch that's going to potentially reduce your system capacity by 30%, who exactly do you go to ask for the additional budget for the 30% more hardware that you're going to need to be able to deliver what you were delivering yesterday? That's quite a difficult conversation to have. Now, one of the important aspects of cloud is that we can change the capacity that we're allocating to our workspaces. So if all of a sudden we go from kind of a high CPU load and a low memory footprint to all of a sudden we need kind of more memory capacity, we can then adjust the sizing of our instances to meet the requirements of today, and we can do that responsively as we need to based on the business requirements. So we don't have to then make guesses. We don't then have to oversize the solutions that we're delivering. We can deliver what's right at that point in time, and even more importantly, only pay for what we're using. So if the performance requirements increase, then we can deliver additional performance, and there'll be a known cost for that. So it's easy to explain to the business what the actual cost of a change will be. So talking about Spectre and Meltdown, again, we're starting to look at kind of different layers of security. So kind of now we're in a position where potentially hardware becomes a attack surface. So the shared operational model of cloud can be a direct benefit to a lot of organizations in that you're responsible for securing the components that you manage, and the cloud provider is then responsible for securing the parts of the solution that they manage. So again, looking at kind of like the PaaS offerings such as SQL, the fact that there isn't an OS there, the fact that there's the hardware is kind of managed by Microsoft. These are all elements that you don't have to worry about securing anymore because they're being secured by the large security operations teams that are managed by these cloud providers. So that shared ownership model can again deliver some kind of real value. So I think one of the things that's quite important is that this is a journey. It's not something you have to do alone. So you can see on screen, we do offer some advisory services around this. We do offer some free workshops to kind of help you understand where you are today and how you and your business can start to gain some value from these cloud services around your workspace solution. Looking more in depth in terms of kind of mapping these services and these capabilities to your business requirements, we offer some more formalized advisory services where we can effectively work with you to define what your workspace strategy should be going forwards and how you can start to consume these services and deliver some real value to your business. So that's what I have. So I think, Chris, I don't know if we have any questions.
So we have a question from Gareth McBain. I think it was one for you, Andy. On-prem costs versus high usage costs in cloud. Do they compare and how much cheaper is the question?
So the short answer is it depends. I think one thing that would be one thing that we've found to be quite important is that I'm sure everyone's entirely familiar with the Microsoft licensing system, and it can be a somewhat scary entity in terms of understanding what your options are. Now, there are many different ways that you can pay for compute. I think what we're finding is that obviously pay as you go in terms of compute is the most expensive. There are various mechanisms that you can do to reduce that compute cost. There are things such as reserved instances, hybrid use benefits, which you can do to reduce your compute costs to a kind of very manageable level. So we're seeing the compute costs being less of a blocker, especially in the last 2 years, because of some new instance sizes that have become available, which give us the ability to deliver some of these user workspaces more cost effectively. Now, one of the things I would mention is that Citrix do have a feature called Smart Scale, which ties in extremely well with cloud providers. So it's basically something that will automatically start deallocating stuff that's not being used. So say, for example, you've got like 1,000 desktops running. If you've got 3 people logged onto them, you can have Smart Scale, which is delivered as a cloud service, sit there and kind of automatically start turning stuff off to reduce your compute costs. So there are services that we can leverage which will reduce the overall solution cost. I think one thing I would recommend whenever you're looking at deploying kind of a large number of instances into the cloud, have a chat with someone who really understands the ways to pay for the compute. So it's not always a one size fits all. I think what we're seeing more these days is that customers are going for a hybrid approach potentially with how they're purchasing compute for workspace solutions. So it could be a case of buying a baseline capacity with reserved instances, and then using kind of a combination of potentially pay-as-you-go and hybrid use benefits for the rest of the capacity requirement. But it is very specific to your working style and the working practices of your business. So it's something that we can definitely help out with. So we've got quite a lot of experience now kind of like crunching the numbers on these. So if you've got any specific scenarios that you want to run through, just reach out to your account manager. We'll be happy to kind of help out with any numbers you might need on that.
I think that goes in general for anything in Azure, really. I know for me, I'm doing a lot of cost analysis projects at the moment. If you've been in Azure for a little while, we generally find that if you then revisit what you're using as an analysis over 6 or 12 months, generally speaking, we can probably find some points where there's some potential cost savings that you may not necessarily be aware of, either to the points that Andy just made, or the fact that because your VMs have been running from an on-premise and maybe migrated, they may be slightly over-resourced when you move them, and therefore either new VM sizes have come out that perform better and are potentially cheaper than their previous incarnation. And it's something that we generally do a lot of work with customers around, just to keep those costs down as new things come out. So just had a quick question around DR for the PaaS SQL side of things, to transition it back into production. So when you do the failover for a PaaS SQL database, the system automatically has one database as the primary and one as the secondary if it's in a failover group. When you either force the failover or it does it automatically, it will make the new database the primary and any other replicas the secondary automatically. And when that database comes back online, you can do a failover back to that database. It will reseed any changes, and it will make that database the primary database again. So it is fairly seamless from a database perspective. It does depend on kind of what you're using it for. So some customers may be treating them separately as the primary and secondary with therefore separate connection strings. Some customers may be using this failover group way of doing things, which is still fairly new. It's not been around that long as a feature. And that will give you also that unified connection string between the two of them. But the failover and the failback, it will always make one primary only, and then it will allow you to move that primary about, and it will reseed any changes where it can, obviously, on that sort of thing. So it is relatively straightforward, and most of it is under the covers. To be honest, there's not a huge amount of configuration to do, which apart from the cost benefits around what we talked about around the fact you've got no virtual machines or networking to pay for effectively or manage anymore. That's one of the other reasons that PaaS becomes so popular, is because it's a lot easier to do things like HA and DR than it is traditionally on-premise as well. So it looks like we don't have any other further questions, but just to say to everyone, thank you so much for giving up an hour of your day. I hope it's been informative and interesting, and we are going to do more of these moving forward as well. As Andy's already mentioned, in terms of certain services that we offer, that also extends to anything Azure-wise that you may have any kind of queries on, from just large migration projects down to just IaaS or PaaS projects that you kind of need a little bit of help with, or even some cost reviews and everything in between, effectively. So speak to your account manager, and if you need any help, obviously we are here for that. But for today, thank you very much, and hope to see you soon.